But thank you so much, Dr. Wang, for joining us. And this is going to be a really cool presentation. So you have 15 minutes and the stage is yours.
Okay, thank you very much for the kind invitation for having me here to introduce a little bit about our work. The University of Chicago. The topic I'm going to present today is our development of a new kind of wearable electronics that mainly includes two aspects. First is with the skin-like mechanical properties for enable the very conformable integration on the skin surface. And then, on the other hand, also can incorporate the artificial intelligence data processing for the health signal that we collect. So over the past 70 years, we all know that the electronics has received very significant developments. And now when we march into a kind of a new era of electronic technology, there are more and more applications that will require electronics to work, to function directly on the human body to collect the human-generated data, for example, for precision medicine or for Internet of Things, or for human-machine interactions or human-robot collaboration. But unfortunately, our view to this is the currently available electronic technology that mainly based on silicon, like inorganic, rigid and brittle materials, don't have such compatibility with the like very soft and the curvilinear and the constantly moving human body. So therefore, to really enable the functions of electronics in these very new domains, what we think that need to be realized is to have the new kind of electronic materials and then further create the device that can mimic the different kind of properties that's given by the human body so as to achieve the intimate integration and even seamless merging, okay? So the main reason that we want to enable the electronics to have the like human mimetic or biomimetic property is all about the quality of data. So basically for this application, as I mentioned, the most important thing is we can constantly generate data with high fidelity, high accuracy. But unfortunately, the currently available wearable electronics, like for the Apple Watch or Fitbit, which has a very significant mechanical and structural mismatch with the human body. Basically, in our view, it's a kind of these devices are just a miniaturized cell phone that you wear on the wrist. We have several issues. So therefore, we need to have a new generation of electronics to mainly bring like three aspects of advantages. First, we want as high as possible contact area between the electronics and the human body, so that the attenuation of the like very weak subtle signal from the human body can be minimized. And then second, since our body, our skin is constantly deforming, when the electronics is attached very conformably, it has to be able to deform to accommodate the deformation from the body. And reversely, we also need the electronics to minimize the invasive reaction or wearing discomfort to the human body. So therefore, driven by all these desires, what we have been targeted at doing is to realize a new kind of electronics that combine, on one hand, the advanced electronic or sensing functions, and on the other hand, with the biomimetic skin-like properties. So under this overall umbrella, like one specific area that we think the wearable electronics can make huge impact, can play a really like a paradigm shifting role is in the precision medicine. Basically, the goal of precision medicine is to provide the right and the personalized medicine for each of the patient according to their specific health status and the response to the different kind of diagnosis. But to do this, there are two things essential. First, you need to collect a lot of data to be able to really learn the difference of the different patients. And then after you have the data, you also need to very effectively analyze the data in the high throughput fashion. So then to support these two major capabilities, we need two kind of technologies incorporated. First, we have, from the previous talk, we have